Welcome back everyone. I am Brij Mohan from Department of Mathematics, Hansraj College, University of Delhi. So we have learned in three tutorials in our previous lectures that how we can use built-in functions, are the basic infrastructure or structure or their properties to write a Mathematica code. In second, we have gone through the different type of plotting or different type of graphics how we can use to create our graphics or plot for our work. And in the third lecture, we used some functions like nsol, I think table was there, and reduce function was there, and other functions, and we used the curly brackets, how we can define our matrices. So in our fourth lecture or tutorial, we are going to understand the programming in Mathematica, that how we can create our own programs to do our work without using our built-in functions. So let's start it. So what we should know first, that is the most important thing before going to do programming in Mathematica. So here we have some bullet points, and you have to go through very clearly, that you have to understand all these points before going to write a program in Mathematica. So first one is defining variable or symbol, because in Mathematica everything you define is not known as variable, but it is known as a symbol. So that's why I have written here variable for you, but actually the name is symbol. So but in general we can call it as a variable. So defining variable symbol rightly means that you have to give the name rightly, like this one. If you want to give name my list, and you have a space here, so that is the wrong way. So that's why you have to give the name rightly. For example, I want to create my own plot, I want to define plot, but that is the wrong way, because plot is already built-in function in our Mathematica. You can define small p, lot. So you can define this word, but you can't define this word, which is nothing but a keyword or a built-in function. So that is the meaning by defining your variable symbol rightly and assigning the right value at right time. So we will go to examples that how we will do that. And second thing is using the semicolon. Semicolon is used to write multiple statement also in a single body portion, and for no output also. So if you want to write x is equal to 3 and you want to execute, your output will be 3, and if you put semicolon after this value x is equal to 3, you will get no outputs. So understand it that semicolon can be used in two ways. The first one is for no output, and the second one is if you want to write multiple statements or multiple line in a single block, that also can be used in that way. Another is if variable is already used in previous calculation, first clear it. It is your variable. For example, you are doing some work and you had defined some x is equal to 5 and you want to use x again, so you have to first clear it. So by clear, and it means your variable name. If you have multiple variables, then you can put x comma y comma z comma like this one. So you need to clear that. Another is defining a function. How you need to define a function in Mathematica. So see very clearly that your function name, let's say f, then a square bracket, then your variable name and underscore is there. You can see here f, function name, square bracket, variable name with underscore. If you have another variable, then put comma, then y, underscore and then square bracket. And after that, for defining a function, you need to use colon equal. That is nothing but set delayed operator. This one is set delayed operator. Set delayed operator means when you are defining a function, it will not be executed at that time. But whenever you will use that function by calling for some values, it will give you the values. And that's why whenever you are defining a function, initially you need to just define it, not execute it. So always remember, use set delayed operator. Its name is set delayed with colon and equal. So that is how we start our function defining, and in the right side you will use your expression, not fx is equal to some expression. So this is the wrong way of defining. Never do that. If you want to do good programming in Mathematica, always use this symbolization, that your function name is square bracket, variables with underscore with commas, and then set delayed operator, that is nothing but colon equal. Another is using relational operator in conditional statement. So conditional statements means such a statements in which you get true or false. For example, something happens, and then if it is true, then you should go to the some statement. If it is false, then you should go to the another statement. So this, at this point you need to check something. So these are called the condition. Then only you will choose some statements, right? So for in Mathematica we use if statement. If something is true, then some statement will execute. If it is false, then some another statement will be executed, right? Another is using iteration in looping statement. Looping statement means that you want to work again and again. A work you want to do again and again. So that means you will use iteration in it, and whenever you are using iteration, then the functions for them are for or while. So two for looping functions are there, for and while in Mathematica, that you can use. Another is if counter needed, then assign it to 0 in the beginning. Counter means that you want to do your programming and some counting is there. For example, you want to find out prime numbers, that 10 prime numbers I need, and you have code for choosing prime numbers, but counter is also needed because you want to count first prime number, second prime number, third prime number up to 10th prime number. And that's why if a counter is needed in your coding, that it should be defined at the starting with the value 0. Or flagging means that something is happened and that is true, so flag is also there. For example, some army is going to war. If armies win, then they will fly their flag. So that means something is happened which is true, so flag is 1. If it is not, then flag value is 0. So you can start in the starting by defining some flag variable or just giving a name flag, or counter for count, like this one. Here count is equal to 0 or flag is equal to 0, like this one. So we will see different examples in our this tutorial, that how we can do programming. So let us understand the defining function again, how you can define, as we have discussed the expression, how you will write. So that is basically the syntax. So you will write function name, any name depending on your choice, then square bracket, your variable with underscore, then set delayed operator and your expression. That is how you define your function. Let's start with an example. Here is f, x variable, set delayed operator, then x square plus 1. So whenever you will execute, nothing will happen. If you execute this first line only, the defining function line only, nothing will happen, because it will not give you any answer, because you are using set delayed operator. Set delayed. Delayed means it will delay. It will not execute at that particular time when you are executing this particular line. But whenever I want the values for some value for this function for let's say f3, then you will execute and you will get output as 10, because 3 square plus 1 is nothing but 10. So you can define a function in Mathematica very easily and you can get answer for some particular value for that function in this way very efficiently. Another example is, for example, you want to define a function f of x sin x plus e to the power x. This is nothing but sin x plus e to the power x. So for writing e to the power x, you need exponential function, and for that you need to use exp, in which e is capital, and in sin is also a function, so s should be capital. So sin x plus e to the power x is, that means, exponential function. And if you want to find out the value for function at value 10, then you will get the value like this one. But you can see here, this is not the value in rational or any other, because n is there. N is for numerical value. So whatever f10 is coming, you just put this into the numerical function, that is n, and you will get the real value 22025.9. Come to the another function with more than one variables. Let's say you are defining a function x with x variable x and y, and the function is x square plus y square minus 3 by using set delay and with underscore, and you can find out the value for function for x is equal to 2, for y is equal to 5, like this one, and you will get the output 26, because 2 to the square 4 plus 5 square is 25 minus 3, and that will come to the 26. So now come to the if statement, and if statement is nothing but conditional statement, remember? Okay. So here is the syntax for that. This is nothing but syntax. Syntax means basically formatting, right? So this is the syntax how you can write if statement. So here, if I with capital, if then square bracket in which you have condition, then comma, then true statement, and f for false statement, t for true statement, f for false statement. So you need to give condition. A condition is given by using some relational operator. Relational operator, you can see all the relation operator in our first tutorial: less than, strictly less than, greater than, less than equal to, equal to, not equal to. Okay, so you can check the tutorial 1 for all the relational operator, and also you will use different examples here, so you will come to know that what are the relational operator we have. Okay, another is if statement, another syntax: condition, true statement, false statement, and if such a statement is needed that that is beyond the true and false, that means something happening, some condition is applied. If it is true, then this statement comes. If it is false, then this statement comes. And if nothing is there, that means not true, not false statement you want, and you want to go to the third option, then you can write also u. And u is nothing but give the if condition evaluates neither true nor false. So if condition is not giving you true or not giving you false, in such a case you can write another statement after f comma u, then u statement will be executed. Now come to one example here. If x is equal to 10 is given, that means x is assigning minus 10, and the condition is applied: if x is greater than 0 or greater than equal to 0, then print is for displaying some text or value. So print is there, print function, then number is positive. So this is the string with double quotes. So print number is positive, then comma is also there, then second statement is there, print number is negative. So we can see this syntax match condition, t for true statement, and f for false statement. So if x is greater than equal to 0, now we can check here x value is minus 10, and minus 10 is not greater than equal to 0 because it is less than 0. That's why it will go to the false statement, and which is number is negative, and your output will be like this one, the number is negative. Another example you can see. So we have here a is equal to 15, b is equal to 10. If a is greater than equal to strictly greater than b, then this is the true statement and this is the false statement. What we are doing in true statement, you can see here, for multiple statements use semicolon between the each statement. As I have already said, the semicolon can be used in two ways. First, for no outputs, and second, for multiple statements. So here you can check, this is the only first statement, that is true statement, but here we have multiple lines, right? True statement with multiple lines. So first one is a is equal to a plus b, so that means a value is 15 plus b is 10, the total value a is now 25. B is equal to a minus b, a value is updated because this statement has 25 minus 10, so that is 15, the value is 15, b value is 15, then a is a minus b, a is 25 minus b is 15, that is 10. So now the last statement, a is 10 and the b is 15. So whenever you call the variable a and b or symbol a and b, you will see a have 10 and b have 15, but initially we have a as 15 and b is 10, so that means swapping is there. Swapping means the value of a will go to b and the value of b will go to a, and that is called swapping. So we are using swapping by these statements, and if it is not true, a is not greater than b, then no swapping will be there. But a is greater than b, yes, 15 is greater than 10, and that's why swapping will be executed. Okay, here also you can check. Another example you can see, let's a student have marks 319 and the total marks are 500, that means maximum marks, and you want to find out the percentage, then you will apply the formula for percentage, that is nothing but marks into 100 by total. So that is the basic formula, right? And you will put n here because you want to find out the real value for that. Now come to the if statement. If percentage is greater than 60, you will write first division, otherwise you will write below 60%. So the first statement is, if percent is greater than 60, then first statement will be executed and the output will be first division, otherwise it will go to the below 60%. So here we can check the percentage for student is 63.8 and the output is first division because it is greater than equal to 60. Now come to the nested if. Nested if is nothing but if you want to use if statement inside a if statement, then it is called as nested. Inside of something, something, then something. Okay, now come to the example. Let's say, as in previous example, we have seen marks is 219, total marks are 500, and we have some percentage, some, let's say here 43.8, this is the percentage output here, 43.8, and here is one first statement, if statement. If percentage is greater than equal to 60, then the first statement is first division. So that is our first statement, true statement, then comma is there. Then again we have written if statement. That means all this statement is nothing but in the false. So if percentage is greater than equal to 5, it will print second division, otherwise third division will be there. So we can check here, percentage is 43.8 and it will check first here, no it is not, so first division will be not there, so it will go to the this statement, then again it will check it is greater than equal to 45, no, so that means second division will not be there, so it will go to the last statement which is the false for this percentage, and answer is third division. I hope you can understand easily how a nested if works. Okay, now come to the for loop. For loop is basic for iteration, that you want to do a work in repeated mode. That means again and again. For example, if you want to write a table, 2 1 is 2, 2 2 is 4, 2 2 3 is 6, like this one. That means you are multiplying 1 2 3 to 2 and you are picking the answer for that. That means you are doing the same work again and again, but with some increment, right? So first see the syntax for that, for writing a loop. So you will write for, then square bracket, then you will write the starting, what variable need to be a started value, then you will write a test, that means condition you will apply, then increment, and then body. So that is the your for loop syntax, which execute start, then repeated evaluates body. Body means your main expression will be this part, body. And four inputs are there for loop. Four inputs are there: start, test, increment, or body. Also you can use decrement also. It's not necessary you will always use increment, you can use decrement also. Okay, but four input will be there always. Okay, so starting, testing, increment or decrement, then your body means the complete expression what you want to execute repeatedly, right? Let's understand it with one example. So I have written here 4 starting with I is equal to 1. So I is my variable in which the loop is depend, and the starting value is I is equal to 1. Then condition is I less than 10. That means I will start from 1 and it will go up to 10. And here you can see I is equal to I plus 2. So what is the step size for I is I plus 2. So it will start with 1. Then the next value will be 1 plus 2, that is 3. The next value will be 3 plus 2, that is 5. Next value will be 5 plus 2, that is 7. And next value will be 7 plus 2, that is 9. So basically we are updating I with one step size, and the step size is our 2 in such example, or in particular this. And what are the last? So this one is print I. That means our body, our expression, what we want to do, we want to print I. So it will start here, it will check condition, then it will print, then it will go another increment, then condition, then again print, then this one, then this one, then this one, this one, and again repeatedly it will do. And if it is false, then it will go out. So you can see the hard progression, how it will execute your for loop iteratively, right? And the answer will be 1, then 3, then 5, then 7, and then 9. So you can understand very easily how a for loop works and what are the our syntax and how we can write a for loop. Come to the another example. Here is another example for 4. So finding sum of numbers from 1 to n. For example, we want to find a sum from 1 to n, or you can write in mathematically I is equal to 1 to say 10. Here let's say n is equal to 10, and finding sum, that means number sum is there, so that means normally I. So how we will do it in Mathematica? There are direct built-in function also is there. So that means you can use sum, SUM, I, and with range I from 1 to 10, and you will execute this function. So you can directly use some function, but as we are understanding that how we can create our own codes, our own programs, so that's why programming in Mathematica is needed. So let's clear it first, and now come to the using for loop, that how we can create our sum without a built-in function. So here you can see, to doing some sum, that means you want to add some value from outside to some variable. Let's say some variable is the beginning, that means some empty space in which you are putting the value again and again, and you are adding and you are updating this space. So that's why the starting value should be 0. Remember it, whenever you are using some sum function, and in the starting if you are not giving the value 0, then your answer will not come correctly. So remember always, so you should start with 0. So sum is some variable in which starting value is 0. Then for loop is there, we start with 1 because we want to find out 1 to 10. So I is equal to 1 starting, then up to 10, then increment will go to 1, 2, 3, 4. That means I is equal to I plus 1. Or in short, you can write also 1 plus plus. That is also the same meaning, and that is the shortcut for post increment basically. But we will not go to the post increment or pre increment now. We will discuss in some another tutorial. So you can write I is equal to I plus 1 here in a simple way. Then you are finding the value for sum by updating that sum, and you are adding the value I. So sum is 0, I is 1, you will put 1, I is 2, you will put 2, and you will add them because starting value was 0, then plus 1 is 1, then you will add another value, right? So like this one, there is a space, name is sum. So you have I value 1, it will come inside. So the what are the starting value? Starting value was 0. So 1 come here, so it will go 0 plus 1, the value will be 1. So it will be 1 here. Then 2 will come here to this sum. So 1 was there already, so 1 plus 2, that is 3. So it will be plus 2 is equal to, now value will be 3, and that's how it's work, right? Remember. So you can create your own programming to do sum. Let's say you want to find out the product of the number from 1 to 10. Similar way you will apply, and for that the starting value will be 1, not 0, because here you are not doing the sum but you are doing multiplication. So if by mistake you chose value 0, then 0 into something will always be 0, and you will not get your correct answer. So that's why for doing the product, starting value should be 1. So that is the product variable, and the product into I means you will multiply again and again whatever I value is coming. So product into 1, that is 1, product into 2, that is 2 into 1, that is 2, then 3 into 2 is equal to 6. Like this one you will move on and you will get your value, and the for loop is applied same as the previous one. I is equal to 1, I less than equal to 10, I is equal to I plus 1, and you will write product is equal to product into I, because in the right side you need starting value, and that is 1. In the right you need some starting value as 0, and you will write product, you will call that particular symbol, and you will get your answer like this one. So you can see another example. For example, you want to find out the prime numbers, or you want to check a prime number. First, let's say checking a prime number. So how you will do it? How you check a prime number? You find out if it is not divisible by any other except 1 and itself, and that's how a prime number is checked. For example, 7 is there, so 7 does not divisible for any number between 1 to 7, right? So here you can apply that formulation or the similar pattern. Here let's say you want to check n is equal to 37. So if it is prime, we will flag 1. Okay, it is not divisible by any number, so the flag is 1, right? So here you can understand the concept of flag. The something is okay, that means flag is 1. If something is wrong, that is flag is 0. That is the meaning. So I have written here flag 1, then the for loop will be started, and we will check by cutting the number from 2, not by 1, because 1 is will divide always any number, right? So for j is equal to 2, j is strictly less than n. So between 1 to n, we will check all the numbers, right? that which number will divide this particular n. And the increment you can see here, j plus plus means j is equal to j plus 1. You can write this one or this one, whatever you choose. Then comma is there here, comma is also there, this one. So first is that is your start, then condition, then increment or decrement. So here we are incrementing it to, and then 3, then 4, then 5 up to n minus 1. So here now you can see if mod of nj, mod of nj means you will divide n number with j and you find the remainder. So getting a remainder is the built-in function is mod. Okay. So if we have applied in body part, if number is divisible by j, that means it will give you remainder as 0. So if it is divisible, that means the flag is 0, right? And if any number will not be divided, that means it will not execute this statement. That means flag will always be 1 because it is not changed. And that's why outer of the for loop we check if flag is 1, print prime number, otherwise not a prime number. Very simple, right? If it is divisible, that means flag is 0. If it is not, that means flag is always 1. So flag 1, print prime number, so print not a prime number depending on the flag. If it is divisible, that means not a prime number. If it is not divisible, that means prime number. So that is how we work. Another example is there. Similarly, you can check for 45. Another example is there. Similarly, whatever you have written in the previous, yes. So that is the same code from n is equal to this one to this one. You can see that we are checking a number and if it is a prime number or not. Now you have to find the prime numbers between 1 to n, let's say 1 to 20, right? So, and how we will do it? You will put here, in previous slide we have given particular value for this n variable. Now what we will do? We will put this n value from loop. That means checking the number. So we will pass number again and again, and this code will execute again and again, and it will give the value if it is a prime or not. If it is a prime, then it will print the value of I, because I is coming from that particular loop. So you can see here another loop is needed for picking the values from 1 to 20. So for I is equal to 2, starting I less than 20, condition, and I plus plus means I is equal to I plus 1. So we are picking the number from this loop and passing to this complete code as in previous slide, that it will check if I is prime or not. If I is prime, then print number and the value for this n, that means nothing but I. So prime number 2, 3, 5, 7, 11, 13, 17, 19. So up to 20 it will go and you will get this type of result. So you can see how efficiently we can do programming in Mathematica. So that is the good thing, that you can write your own codes, right? Okay. Come to the another example. Let's say you want to find out the prime numbers between 100 to 20. So what we will do? We will just change here, nothing else. Condition in the previous slide was 20 and here was 2. So now we will just put 100 here and 150 here. So starting and ending, and all code is same. Then from 100 to 150 you will get all the prime numbers here. So similarly we can use different examples. For example, here finding the largest list in the given list. How we will do? You will pick the number, you will store in your maximum, and you will compare to the each and every element. If this picking element is maximum from all, then your answer is there. If it is not, then we will pick whatever is maximum. For example, here we will start with 12. Let's say this is our maximum value, right, largest value, and by compare it 12 34, this is maximum, so variable will go this one, cut out from this one. 34 96, yes, 96 is bigger than 34, the max will be this one. 31 is small, no. 78 is small, no. 65 small, small. So the last max variable was on 96, and that is how you find out the largest number. The same is written in code. Here we first will define how many numbers are there, because if we want to apply a loop, that means starting and ending should be there. So that's why len is one variable I have defined, and you will use length function to finding a length of a list. So 1 2 3 4 5 6 7 8 9 element there, so 9 will be our len. Then we will pick the max is equal to the first element, and now you can remember in the last tutorial we have understand then how we will retrieve the element from a list or matrix. That means name 2 times square bracket position and 2 times square bracket close, right? Same. So that is max is 12 in the starting. Similarly, we will go to I is equal to 2 second position to the end position, and by incrementing position value, if list I is greater than maximum, जो भी list, that means whatever list element is coming, let's say second position 34, we will check if it is greater than max, then the max will be the next element, and we will do it again and again to going to the last value, and at last outside of it you will put the max variable, and whatever max is there you will get your answer as 96. So you can understand is very easily how you can do. Similarly, you can search an element. This is nothing but the same type of code as you finding the maximum. Now you are searching something. That means you define what you want to search, and you will compare this end to your list elements. How many list elements are there? You will find out by len. Len is equal to length. Then you will check if a list is equal to n, right? Ith position of a list, if it is same as your number what you want to search, then you will find print element found at position, and you will print the positions. Now you can see here 78, and 78 is here, again it here. So this is our 5th position and this is our 8th position. So you have one particular element 78 at 2 different positions, and that is how you check, right? And the same type of code we use for finding maximum, minimum, or searching something. So same examples are there that you can do matrix multiplication of 2 matrices. So you will pick first matrix, let's say A, another is B, and that is 2-dimensional matrix, and you will multiply row by column, and you will find out the matrix multiplication as in a third matrix, right? As your answer is in third matrix. That's why the third matrix P is taken in the starting, and the starting value is 0, because if you want to use some variable from a list or matrix, then you have to define it before using it. So that's why I have picked 2 cross 2. So this matrix is 2 cross 2, this matrix is 2 cross 2, and this matrix is also 2 cross 2. So that's how it works, and you will start, because the order is 2, so you can see n is equal to 2. Then you will write 2 loops, that is in nested loops, right? Loop inside loop, loop inside loop, and the simple formula. How you will write row by column? This element into this element, let's say 3 by 3, this element to this element, this element into this element, this element into this element, and you add all the multiplication, and that is the formula, because that, let's say this is A, this is B. So here you can see AIK into BKJ, right, for column, that is for row, and that is for column, and you will add this position, every this one, then plus this one, then plus this one, and you will add, because we are using sum here, and as I have already said, whenever you are doing such type of sum, the starting value should be 0, and that's why we have defined the third matrix with 0 value, right? And you will get your answer in P, and then you can check matrix form P will be like this one. And if you want to see if your code is good or not, is correct or not, then you can check P equal to A dot B, because Mathematica also do A dot B means matrix multiplication. So you can check if our P is same as the A dot B, that means matrix multiplication, direct matrix multiplication by Mathematica, and you can check for true Q. True Q means if it's checking if it is true or not, then it will give you the answer true or false. If it is written as true, that means your code is okay, otherwise you have to correct your code. Similarly, you can go for 3 by 3 matrices in the same way. Matrix multiplication for different order, for here 2 by 3 and 3 by 2, and this should be common column for the first matrix and the row for the second matrix should be there. So that is how you will write MNQ, the first loop, second and third, MQN, and that is the way how you can use different order matrix by to multiply. If it is not common, then you can pick some condition also in the starting. If this value and this value is not equal, then you can skip all the code and you can create some error, right? You can do that by using if statement. So there are different examples you can understand in the same way. Now come to the loop while. So let us understand the syntax for it. First, while function is there, W is capital, then two argument is there. The first one is test and another is body. So as in for loop, we have 4 arguments, right? Start, condition, increment or decrement, or your body. But in while loop, you have only 2, test and body. So we will understand it. And you can use while loop for your for loop also in the same manner. But there is a little bit difference that while use is mostly used than for, because while work without your start and increment, and that's why while is more usable than for. But for is easy to writing because everything is in argument only, and that's why for loop is used, right? Okay, come to the here one example while loop how we will write. So you will start outside, that is start as in for loop, start, then while condition is there I less than equal to 10, then your body is this one, the complete is body, this is the body part in your while loop, right? So how you are using while loop, print I, then you can see semicolon is there, and semicolon means that means you are using multiple statement. So you are doing your body print I, but with multiple statement you are telling the increment. Now you can see in for loop we have arguments in function at the defining time, right? But in while loop we have starting the outside and you can put increment in your body, and this is the same as for loop structure, and you will get the same output as we have got the first example in our for 1 3 5 7 9, right? You want to print values from 1 to 10 with increment I is equal to I plus 10, I plus 2. So the step size is 2. So 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7, and so on. It will go to the 9, because after 9 it will be 11, and I less than 10 will be false, and it will go exit, it will go outside, right? Now here you can see I have written for loop also, that for I less equal to 1 is starting, condition, increment and body, and how while loop is working as in a for loop and how you can use it, you can understand that. Okay, come to one another example, and here is example without initialization. That means here is no initial value, that means start is not there, right? So you can see example while is directly started, while true N is take input, enter an integer. Input means by user you want to pick some value, then you can use input function and it will pop up a window in which user will type some number from keyboard and then hit enter, then it will take some value. For example, let's say I will take first 23, I will put value 23 and hit enter, then it will go to the if statement. If not integer q, that means if it is not an integer what a user has given, right, it will check or n less than equal to 0, or in both cases if it is true or if it is true it will break. And if n it is basically checking the integer, so if it is true then okay, it will go to the statements, then it will print n is equal to prime n q. So it will check the given number is prime or not. So it is prime q function for checking the number if it is prime or not. So directly you can check the by using this function a number is prime or not, right. So I have given 23, so it will go 23, yes, 23 is prime. If it I will input as 45, false. If I will input 67, that is true. So it will go again and again because it is giving you the value true. But if you want to stop this loop, you have to put just -1 like this one, or -10 and anything. So or not integer 1.5, it is real. So whenever these, any of these, right, any of these is true, that means loop will go exit and this loop will be terminated. Here is another example, finding the sum, same as for loop you can do. Another product you can also do for same code for for and while. So thank you everyone, thank you so much. I hope you have now understand then how we can use our own programming to create our own programs, right, to writing a program using conditional operator or loops as we have seen here, for loops and while loop. So see you in the next tutorial. Till then, take care, bye bye.